Hello students, I welcome you all to this class. This is mathematics class, and today we will be continuing the study of this factorial notation. In our previous class, I told you that if you have a positive integer n and you want to find the factorial of it, so this notation is the factorial notation. We saw that in our previous class. So if you have a positive integer and you want to find the factorial of it, so I want to find n factorial, so you are going to expand this down to 1. So you are going to expand it down to 1. How do I expand it down to 1? You write the number, the next you multiply it by the lower number till you reach 1, right? So I'll have n first, then I will multiply it by what? An integer smaller than n is what? N minus 1. The next one, the one smaller than n minus 1 will be what? N minus 2. So this is how you are going to expand it till you have what? 3, 2, 1. So you expand it till you reach what? 1. So this is what we saw in our previous class. And we say that assuming you have something like 5 factorial, that is the same thing as 5 times 4 times 3 times 2 times 1. Just using this. That's if n is what? 5. Assuming that n is 5. So you write 5 first, just as you have n first. Then you minus 1 from 5, just as you have n minus 1. So if you minus 1 from 5, you have 4. That's how you are going to go down to 1. So next one, you multiply. Okay, this is how you will be going down till you reach what? 1. So you have 5 factorial is 5 times 4 times 3 times 2 times 1. So they ask you to simplify n factorial plus n minus 1 factorial divided by n plus 1 factorial. So this is what we'll do in this class. So in our previous class, the one we had in our previous class has to do with two fractions, and we found the LCM so that we can combine the two fractions as one fraction and do the necessary simplification. So, but this one we just have a single fraction, so we don't need to find LCM. So what we have to do is just to see how we can simplify the numerator, simplify the denominator, and see whether some things can cancel, and we now have our final result. So we have n factorial, we have plus n minus 1 factorial divided by n plus 1 factorial. So the question is, how do we simplify this? We have n plus 1 factorial down here. We have n factorial plus n minus 1 factorial at the numerator. So because at the numerator, if you look at the numerator, the one that is smaller is what? N minus 1. N minus 1 is smaller than what? N, right? N minus 1 is smaller than n. So n minus 1 factorial is smaller than n factorial. So what we can factor out from the numerator is the smaller one. So it means if we are factoring the smaller one from the numerator, we have to simplify the denominator to get that smaller one so that they can cancel. So before we factor n minus 1 factorial, we must, in this first term at the numerator, we must have n minus 1 factorial. So we can simplify n factorial to get n minus 1 factorial. So this n factorial, you write n first, right? Next one, you remove 1 from n. You have what? N minus 1. Isn't it? So we have n minus 1. And the second term, the one we want to factor out is what? N minus 1 factorial. So we have gotten n minus 1 at the first term. So we are going to stop here. And because we did not expand n factorial down to 1, we are stopping at the middle. We have to put was factorial. So this will be factorial. So we have n multiplying n minus 1 factorial. Then next term we have is what? Plus n minus 1 factorial, right? We have plus n minus 1 factorial. Plus n minus 1 factorial. Isn't it? So divided by what? What do we have here? N plus 1 factorial. So because what we want to factor out is n minus 1 factorial, and we want it to cancel something down here. So we must expand this denominator to get n minus 1 factorial as well. So I'll write this n plus 1 factorial as n plus 1 right? So you first of all write the quantity you have, then you remove 1 from it. If you do n plus 1 minus 1, you are going to have n. Then remove 1 from n, you are going to have n minus 1. So I've gotten n minus 1, which is at the numerator. Then what do? We are going to stop here. And because we are stopping at the middle, we are going to put what? Factorial. So we have expanded the denominator. So we are going to continue. We can factor the common term at the numerator, n minus 1 factorial. So we factor n minus 1 factorial at the numerator. Then what is remaining at the first term? What is remaining here is what? N. At the second term, at the numerator, what we have is n minus 1 factorial. If factor it out, what will now be remaining here there will be what? 1. So all divided by what? What we have down is n plus 1 multiply n minus 1 factorial. So this is what we have. But clearly, n minus 1 factorial can divide n minus 1 factorial, right? So what you now have at the numerator is what? N plus 1. Then what you have at the denominator is n plus 1 multiply what? N. Multiplying n. But if you look at this closely, something can still divide. N plus 1 can divide n plus 1, right? So n plus 1 divide n plus 1, I have 1. N plus 1 divide n plus 1, I have 1. So what I have at the numerator is 1. Then 1 times n, I have what? N. So this gives us what? The final simplification of this expression. So we are going to, in the next class, we'll be treating what? Permutation and combinations. See you in our upcoming class. Bye.